So whenever you like.
Great. Hello, everyone. Thank you for joining us today for another Zoom edition of ODI Fridays. My name is James, and I'm a consultant at the Open Data Institute, or the ODI. And today our guest speaker is David McKee. David is the CEO, CTO, and founder of Slingshot Simulations, an organization which helps people to make better decisions through the use of simulation technology. Recently, myself and some other colleagues from the ODI have been supporting David with their Breathing Cities digital twin project as part of our collaboration with the Lloyds Register Foundation, and I'm sure David will touch more on this later. Today's lecture will explore some of the key challenges as to why simulation and digital twins have yet to deliver, and highlights why some of these can be solved today. Before handing over to David, can I please ask that everyone who's joined us today can turn off their microphones and cameras during the presentation. You'll have the opportunity to ask questions at the end of the presentation, and if you do want to ask something, then please submit your question using the chat function. And after the presentation, I'll ask people one by one to unmute and ask their questions. I'd also like to remind you that we are recording this session. Once again, thank you for joining us today, and now I will hand over to David.
Thank you. Great. So it's a pleasure to be here virtually. I do miss being able to present in an auditorium, interact with people, and normally I would say please interrupt me, but in a virtual world we seem to be now living in, it doesn't quite work as well. So for the next 20 minutes or so, I'm going to take a dive into why, as James said, simulations specifically and digital twins haven't delivered yet, and why potentially 2020 could be the year of opportunity. Back in 2017, Gartner published one of their market reports, as they do every year, and they predicted that by the end of 2020, which is scarily not far away, 50% of billion-dollar companies would have a digital twin or simulation program of some form. That, however, raises a really interesting question: is what about the non-billion-dollar companies, who that means probably only 1 or 2% of them do? So what is it? What's changed? Is there potential for those companies to really get on board and embrace the efficiencies and optimizations that are available through simulation and digital twins? And let me give one example before I dive into this presentation. Imagine you are a 3PL, a small logistics firm. You could even be the size of a DHL, or you could be smaller. But you're competing with Amazon. Amazon can afford to throw billions of dollars at digital programs to optimize, to simulate, to drive every inefficiency out of it. So every inefficiency in their warehouse, the fact that I can today order something here in Leeds and have it delivered this afternoon is crazy. Smaller firms just don't have that capability to understand everything from trunking to last mile delivery. Or if you're a local authority, how can you actually understand, without spending hundreds of thousands, the relationships between traffic forecasting, air pollution, and lung disease? It is very easy, if you're a data scientist, to go and say, actually, look, all that traffic is causing 25% of child lung disease cases. That's a really bad headline. But actually, in order to do something about it, you need really advanced tools, advanced skill sets to be able to analyze those. And that just hasn't been available to organizations recently, well, in the last 20 or 30 years, at least at a price that they can afford. So let me just give a bit of an overview. So I'm going to start with a brief definition of what is a digital twin from our perspective at Slingshot, which is quite close to the definition of the Centre for Digitally Built Britain and the National Digital Twin Programme, as well as the Digital Twin Consortium, which was founded back in April by the Object Management Group and Microsoft. I'm then going to dive through some of the challenges that we've seen over the last decade in particular that have taken us at Slingshot to the position we are now. And as James mentioned, we have our Breathing Cities project, that really was a motivation to try and show what is possible, particularly with that added dimension of open data. First of all, a tiny bit of background on myself. So as mentioned, I'm the CEO, CTO, and founder of Slingshot Simulations, too many titles. Slingshot is supported by the Royal Academy of Engineering through their Enterprise Accelerator program. And we've been working on digital twin interoperability and integration. So webs of digital twins, as Network Rail calls it, or co-simulation, as is known in the manufacturing community, since about 2013. We are a spin out from the University of Leeds, where we were doing research in this space for a long time. And our background is probably quite different than many people you would talk to in this space, in that we're cloud computing specialists. Our background originally was around how do we scale up data science to the scale of data centers and beyond. And we've been working towards our concept of an internet of simulation. How do we collate these things together in a democratized fashion? But enough about me and our background. So how do we see digital twins? And for us, the definition is relatively straightforward, but there's a lot packed into this. It is a digital environment that reflects on, mirrors, and evolves ahead of the physical environment or service to facilitate smart decision-making and storytelling. Let me break that down very slightly. We deliberately use the phrasing a digital environment and physical environment to not restrict ourselves to building assets, but to also talk about potentially our natural environment. So the terminology here is very important. We could be talking about geological systems just as much as we could be talking about BIM and other aspects. Digital twins have to be useful, and they have to have a so what. And that needs to be about storytelling, but it needs to be about making decisions, forecasting, giving insights. And that really needs to hark back to what we used to refer to as these smart objectives that for some reason don't seem to come up as much anymore. So why are we doing it? What are we using it for? For us at Slingshot, a digital twin is about helping make smart decisions. And it is a tool, it's not the end goal. It is a tool that you can use to measure those decisions, and it needs to be done in a timely manner. And that is really important. Often we can say, look at this wonderful digital twin. It's so high fidelity. It looks great. That's brilliant. That could be a computer game. But it has to have a purpose that benefits the user, the business, the local community, or wherever appropriate. So why hasn't simulation as a whole delivered on a wide scale? And it's three primary factors: complexity, scale, and cost. By complexity, I'm referring to the fact that to model, it could be an engine, you need to have a hugely detailed knowledge of what you're doing. But the number of parameters and variables can be in the thousands or tens of thousands. Take an example of the automotive scenario. We spent 5 years working with Jaguar Land Rover looking at engine emissions. So we were doing digital twins of everything from the engine down through the powertrain in terms of the transmission system, the electrical system that controls that, and through the differential to the tires. At any one coupling between two parts of that, there were over 500 parameters that needed to be tied together with their units, with time integrations and other things like that that I'll mention later. Then add on to the wonderful example that we've all heard of, which is you have to deal with units. So I've got a good friend who works in the space industry making mirrors for satellites. And a big problem that they have is that these are manufactured in the UK and they're manufactured to the most accurate millimeter. The specification comes over from NASA, specified in inches. Unfortunately, sometimes they don't specify that they were using inches. So it automatically goes through the CAD system and it got manufactured in millimeters. That is several $1 million of wasted money just because they've forgotten to specify units. Really simple complexity issue that could be dealt with, but result in a major cost issue. But then if we're looking at digital twins in the way we're not talking about them at places like the Barcelona Smart City Expo and others, where we're talking about entire cities. You know, these could be 10 or 11 million people in London or 3 million people in Leeds. Every person, every car, every crossing, every train, looking at the dissipation of pollution from those, the level of detail is astronomical. And we need to find a way to manage that from a computational perspective, putting it on the cloud, putting it on an HPC. But then an HPC costs millions just to buy. How do we do that? How do we deal with the complexity that also comes with scale? And also the amount of data. So to give you an example, the project that we've been doing with ODI, we were generating over 10 gigabytes of data per second just for a small simulation of under a square mile area, because of the level of fidelity that it was involved. And that needs stored somewhere, it needs processed. And of course, underpinning all of that is cost. Not just the cost of the things that we've just described, but the cost of the individual person, their salary, the level of expertise required, the training that goes into that, and then the time required to deliver it. And the current environment we're living in is actually a really great example of it, unfortunately. So as we look at COVID-19, it is not helpful for us to deliver a simulation digital twin that helps us understand how to socially distance better if we deliver that project in 18 months' time. Hopefully this will all be gone and done by then. We need those results now, or at least within a couple of weeks. If we're talking about doing it in schools, we need the results in a timely fashion that mean we can deliver it before September and make decisions based on it and potentially make changes either to buildings, to layouts, etc. Incredibly complex. So that's a high level. Let's just quickly dive into some of that in a bit more detail. So simulation, and I'm referring to simulation as one primarily part of digital twins. For us, that is the primary area. There are other areas that primarily would fall under the banner of dashboarding and just straight data analysis of static data. But that we can keep for another time. Simulation is, of course, it's a highly specialized task. Highly skilled simulation engineers in the US can charge easily $300,000 a year. SMEs cannot afford that. License fees for simulation software can easily run to £20,000 a year per user or more, sometimes in the hundreds of thousands. So that is a real problem. But beyond those things, let's assume we get rid of that. There are 4 key challenge areas from a technical perspective. There's the time to do the modeling, to integrate data, to do that analysis. Every new data set, whether it's OpenStreetMaps, whether it's LiDAR data, whether it's some other strange format that some client has. And then the time to run these things in a timely manner. The complexity, as we've already mentioned, and there's 3 parts to that. There's the complexity of the domain you're modeling. And I often describe this with a slight anecdote. In order to build a digital twin, you need 3 people, each with a PhD. You need the person who has the PhD in the domain you're modeling. So that could be automotive, could be transport, whatever. Then the simulation tools themselves are so complicated, you need someone who's an expert in using the tool itself. So that's another person. Might be the same, if you're lucky. But then in order to run it at scale, you need someone with a PhD in computer science who can actually deploy these things at scale, manage the network infrastructure, manage the databases, all of those. And I've yet to meet someone with those 3 PhDs. I had a supervisor who had 2 PhDs for some bizarre reason. But even then, they were in the same subject area. So actually, in order to get over complexity, we need to make some of those processes easier. And that is enhanced by the fact that there's incompatibility between tool sets. You'll have models from one world that are not compatible with another. And then, of course, there's a really fun challenge, which is when you start mapping these things together, you have to understand the parameters, whether it's units, such as imperial to metric, or there's something known as temporal and causal consistency in terms of when you map things together. And the best example for this is, which I would normally do in person, is imagine that we have 2 people standing on opposite ends of a corridor. They're blindfolded, they're not allowed to talk. And we ask them to walk and meet in the middle and to shake hands. They're not allowed to talk and they're blindfolded. in the probably a dozen times I've done that demonstration, they have always either completely missed each other or bumped into each other. They've never managed to actually reliably meet in the middle and shake hands. Now imagine how much harder that is to do the black boxes of software with models that are defined by different companies, potentially in different programming languages, potentially in different languages entirely. These need to be matched together and you get some interesting things that happen. And here's a really simple diagram that actually shows that. So imagine we're modeling the speed of a car. And due to the way computers work, we actually end up with jumps every time we sample our data. But actually that jump of sampling of data, which is known through a technique known as either zero or first order holds, which is commonly known in the simulation industry, actually causes an infinite gradient, i.e. the vertical lines of the red bits, where it suddenly jumps because we've got a new piece of data. In practice, that means that in your model, in your world, you might have the situation of a car suddenly teleporting between two locations because your data suddenly tells you that it's somewhere else. That obviously is not practical. That could result in a whole lot of problems if you've made decisions based off of that. So that needs managed. And there's a lot of techniques that can be used to smooth that out to make it more accurate. Beyond the technical challenges, and the one area I've not touched on so far there is the security challenge. So how do you actually, in all of that, create an IT infrastructure that is secure, looking at certifications, whether it's Cyber Essentials, ISO 27001, SOC 2, etc. How do you ensure that your infrastructure has two-factor authentication? There's also social challenges when we start trying to integrate these things together. How do you understand the ownership and the liability? How do you get people to be willing to share their data in an open manner or open enough manner? And this is going to continue to be a real challenge as we look towards building a web of digital twins, an internet of simulation for cities and our country and the world we live in, which is very much on the agenda. But we need companies to be willing and individuals to be willing to accept the risk that as soon as you share your data, you're exposing what you potentially are doing, which can be challenging. But then also understanding that doing that, we want to protect those individuals as well to make sure that they won't get sued for a mistake they might have made. So we need to really understand that really carefully. And of course, we've already mentioned the cost. A lot of these challenges nowadays have been solved, or at least are a lot easier to deal with. For us at Slingshot, we talk about the 3 C's of large-scale simulation and digital twins: computation, collaboration, and communication. So that means we can scale through the elasticity of cloud computing. The biggest simulations we've run recently go up to over 5,000 servers that can be scaled up in an instant, and we can run simulations in real time as a result. There are many evolving standards, whether it's through CDBB or whether it's the Digital Twin Consortium. There's web standards out there through OpenAPI 3.0 and the IEEE high-level architecture. There's a set of standards that are starting to come together that we really do think will help this form a consistent approach, but hopefully people will adopt them. But there are underlying challenges, and I've got a kind of call for action at the end, which is really around those social challenges. Is actually we do need more open data, and we need to have a bigger conversation around which data can we make open, how can we motivate organizations to do that more, so that we can, whether it's through data institutions or other patterns, other business models, we can actually start to build this web of digital twins. So at Slingshot, assuming all of the above has been solved, and we've touched on a lot of those from a computational perspective, data perspective, and we've tapped into a lot of open data sources, which I'll mention in a moment. What does it mean for us? So our vision at Slingshot is really about creating digital twins for anyone, about democratizing them. And that means that a digital twin facilitates the rapid prototyping of smart systems using a level of machine learning and must not require any coding. The users, we cannot expect them to be software engineers or data scientists. It could be a warehouse manager, a counselor, a traffic planner. It doesn't matter. They need to be able to use these systems for their benefit because they're the domain expert. The software engineers are not. As I mentioned at the beginning, related to COVID-19, we need to be able to do this in days rather than the months and years that it typically takes. There's a wonderful example by Dassault Systems, and that was actually showcased on the National Geographic, where they did a wonderful digital twin of Singapore. But that took a very long time to build. Brilliant. I highly recommend looking it up. The whole hour and a quarter is available on YouTube. But it would take a long time, and it's definitely not accessible to an SME to pay for that. We've already mentioned it needs to be smart, it needs to have a purpose, it needs to have a reason for doing it, and digital twins have to do that. Too often as technologists, and we can get on board with an idea, think, oh, this is great, this is really cool, look how amazing it is. Actually, that's not the reason. It has to have a benefit, which can be really hard for me as the founder of a company with a vision of saying, look, yes, get up behind this. Every day I need to pull myself back and say, well, why are we doing it? What's the benefit we're bringing to the users, to the stakeholders? And in our approach, we are very much working towards a flowchart style notation, drag and drop, something that they're very familiar with, getting inspiration from the computer games that everybody is now familiar with. So that all being said, we've been very fortunate in our partnership with ODI. And I'm not saying that just because this is hosted by the ODI. I really do think it has been a great partnership, and there's some really great wins that have come out of it, was to showcase the potential for building digital twins from open data to drive real benefit and help decision making. So through this, we pulled in a whole range of open data sources, from OpenStreetMaps to NASA shuttle radar topography mission data, which was originally done in, I think, around 2005, and then I think 2014. We're just at the moment, I am updating that to include European Space Agency data, which includes ground movements to millimeter accuracy, plus or minus 1 millimeter. We've got published number plate recognition data with pollution profiles for different cars, published either on DFT data or places like Data Mill North, which is an open data repository in Leeds, and other things like Postcard.io. Putting all this together creates a baseline model that we are able to use and then feed it more data on top. So we've had our vision, we've got our imagination of what's possible, we've fed this some open data, and I really would put a call out there for anyone who wants to say, could we add this other open data? We'd love to hear from you and add more in there. And then we add on more data, whether it's from a commercial client, whether it's contextually specific, could be personal, whatever's appropriate. And then you do something with it and have some fun and hopefully make some real decisions. All of those data sets result in a view. This is a data view. So this is kind of wearing the sort of the more nerd hat on at the moment, where this represents a geospatial representation of those data sets, where every line, circle, shape, each blue dot, each white circle, everything in there is a data point or a data set. And we're using the geospatial referencing, whether it's specified in longitude, lat, UTM, or Ordnance Survey, Eastings, Northings. They are pulled together, collated, which allows us to explore that and present this in one unified fashion without actually compromising the data, the original data itself, which is really important. It's also really useful because it means we can actually show to stakeholders who will look at that first image and say, oh, that's just complicated. And you can actually show them their city, their building, and say, oh, I recognize that train station. I recognize those hills. I recognize the town hall. And you can then overlay the data and show it in that context. And you can start to say, actually, here are people moving around. This is what's happening. This is what's actually happening. So an example of that is it would be able to play back scenarios of data. This is just some still snapshots of an area in the center of Leeds, this is populated from that data to say this is the traffic going there. One of the challenges we did, of course, have was we've had to go back to pre-March, mid-March data, there's been very little traffic in Leeds. So looking at that and doing something with it. But that really provides an ability to tell stories. So kind of pulling that all together, I think it's really worth, there's some technical challenges that remain to make integration easier, but actually the social challenge around sharing data. We need more data to be shared, and preferably we need to start coming together around unified standards, unified formats. It will make life a lot easier. But also, there's some things we've learned. So all of the models we've shown there, there's no high fidelity imagery. We're not looking at photorealism. There are use cases where photorealism really does help. And we interviewed some experts at the University of Leeds where they were looking at the benefits and disadvantages of photorealism in the VR, AR sense for digital twins. And their experience was that actually, if you go with photorealism, you risk causing more problems than otherwise. In the sense that if there's even a small error in a photorealistic setting, could be a footstep slightly out of joint, the human brain is really good at spotting that. And actually can result in things like simulator sickness and other things like that. Whereas if we don't try and trick the brain into thinking we're in a fully realistic virtual world and go with more of a cartoon, lower fidelity model, the human brain is able to understand that and actually able to deal with those discrepancies and is therefore able to do analysis much better. So all of that being said, where do we go from here? Well, this has been an interesting few months working with the ODI, exploring this work. And we've now just started a phase 2 of this in partnership with Innovate UK, Leeds City Council, and Mark MacDonald, where we're kind of going under the Breathing Cities banner and calling people in place and emphasizing the focus on COVID-19, looking at social distancing inside and outside of buildings, and really saying, actually, how do we now deploy this? How do we make all the data integrations that we've done during this project available? How do we find the right framework, the right platform for it, the right business model around that, that is suitable to make it as open as possible, whilst accepting that there are costs associated with it. But there's also a core here is that, if you're interested in helping with this or interested in using this, help us identify some more data sources. And I'll finish with just one question, which is, what do you think a digital twin would look like for you? And then how could we, or how could other players in this space help you achieve that? So thank you.
Lovely. Thank you, David. That was a wonderfully interesting presentation. We've got a little clap there from Jonathan. I think now it's probably time for questions. I don't see any questions in the chat, but if anyone would like to put questions in the chat now, then please feel free. It's interesting that you asked that question at the end, David, because I think that probably I would have posed a similar question to you, in that I'm interested in what you want to see next coming out of cities in particular, around the kind of endorsement of simulation technology and digital twins.
So that's really interesting. So supposedly this, if COVID-19 wasn't happening, it wasn't going on, which we all wish it wasn't, this November, the Barcelona Smart City Expo would be celebrating its 10th anniversary. And unfortunately, it's been delayed by a year. But what was interesting is last year, 50% of it was sensors. There was lighting sensors and so forth. And there's still a question around all these different IoT standards, all these different data, so many different data formats that were all incompatible with each other. Whether it's from CCTV to ANPR cameras to footfall sensors, great, loads of cool stuff, but it just doesn't work in the same sense. So that means it's really difficult to go to a city and say, I don't know whether it's Sheffield, Bristol, London, whatever it is, and say, right, we can just roll this out in a cost-effective way. Because at the moment, there's that huge upfront cost, which says we need to do a consultancy piece to unify all your data formats, to support them all, and then we can reduce the cost. But there's no way even Microsoft isn't going to support 10,000 different formats. They'll only support 3 or 4.
That's really interesting. I think, and apologies if this was covered in your presentation already, but we are talking quite a lot about the UK, I guess, and in the project we talk a lot about the UK. Are there any leading practices that you're seeing coming out of other countries around the world?
So I think that's a really good question. I mean, Singapore is just worth looking at. I mean, they've got a digital twin of Singapore. I mean, it is phenomenal. Their digital twin is being used for planning up to the year 2050. You know, they've built tunnels for roads that they don't yet need because they know they will need them in 10 years' time or 20 years' time. So as they're expanding, because they're building out into the sea a bit, they've built that in. They've built in the space for infrastructure that they might need later, which is phenomenal. I mean, wow. So, I mean, they're definitely worth looking at. You've got a few of the Nordic countries. There's definitely some interesting work there. Spain is also doing quite a lot. Probably one of the most interesting companies that we used to keep an eye on, fortunately they've had a few political problems, is Sidewalk Labs, which is part of the Alphabet group. So they're based out of New York, and they just were in Toronto as well, and they've just moved out of there, and they were looking at smaller, actually practically building it, because they had the might of Google behind them. So they're worth looking at, and a great vision about doing it for the good of society as well.
Brilliant, thank you. We have a question. I'm going to go with Jonathan first, because I think because Hannah is ODI and I don't want this to be an ODI Q&A. So Jonathan, if you'd like to unmute and ask your question.
Oh yes, hi. Thank you very much for this event and the talk. So so I'm from NSC Laboratories in Europe, in Heidelberg, Germany. And so we do a lot of projects in cities also in the past, like smart cities, a bunch of EU projects, or also projects for business units. And also lately we have digital twin is like kind of this buzzword a bit, and like upcoming topic. So I'm quite interested. So what you see like as the kind of a key application or killer application specifically for cities of digital twins. So why would I go through this effort of like integrating these different data sources, all these sensors, and creating the simulation environment? So what do you think is key? Is it like mobility? Is it like energy? I don't know.
Okay, that's a really good question. And I think there's actually more than one answer, which is time dependent. So we're in a really strange time at the moment, and we're actually seeing a lot of cities starting to move towards digital twin adoption really quickly due to COVID-19. Because they want to understand how people are moving, because we're all behaving so differently than before. So we want to understand how people queue up outside a shop, because we have less people out in the shop. So we therefore have a queue outside down the sidewalk and the pavement, but then people have to step into the road to avoid them and keep 2 meters away from them, or 1 meter, or whatever it is. But then that's taking away from space on the road, so we have less space on the road, which means traffic starts queuing, which means we have more pollution, even though we have less cars on the road in total. But we also have less people taking public transport, because they can't socially distance in the same way. So you end up having more cars on the road. You can see where this is going. So although we've got this wonderful situation where the pollution levels of Europe plummeted, I mean, they plummeted by just over 60% at the peak of lockdown, it's now going to rapidly go up. And we've had this opportunity to embrace that. So there's a kind of a current situation which is really unique. I think from our perspective, and this kind of sits very much at the heart of what a lot of our team really are passionate about, is there's an environmental side to this. If we truly want to understand the environmental impact from consumptive and regional and climate change, then we actually need to have better insights in terms of what's actually happening. So I think there's an environmental understanding in terms of what is happening in terms of traffic, all of that. Longer term, there's actually some really interesting things about, we're going to see more automation. The best example, of course, is autonomous cars. And as we look at that, for that to work, it needs to almost be part of a city operating system, which in essence is a digital twin with some more nuanced features from a safety perspective and so forth. So that's where I see it going, but it's going to take a while to get there. I think every city will be slightly different. I think mobility and transport is the place to start. But personally, I think from an environmental perspective with the focus.
Just a quick follow-up question. Like the kind of insights you get like on mobility and like you said, also now with COVID-19 or these distance rules, is it like partially based on some sensor data you get from the city and then partially based on some simulation?
Both, absolutely. So typically with footfall data, you might have, let's give an example of a lot of train stations. You will know the number of people getting off the trains and going onto trains, roughly. You know the number of people based on sensors who are leaving and exiting through different entrances. That is it. So you've got this point-based. You might be able to, some systems will match them and be able to tell you that they're the same person. That's really helpful. But you have to almost make it up in between, based on either observations, based on research in terms of pedestrian movements. You start to refine it. And that is another thing, is that you're initially going to get it wrong. And you accept that. So what you then do is you then show it to the station manager who spends their life observing and he'll say, no, I'm sorry. People don't walk that way. They walk this way for this some reason. And then you update the model to reflect that. So it is a bit of both. The more sensors you have, the more accurate it becomes.
Cool. Thank you very much.
Lovely, thank you. Let's go with Christian's question next. Christian, would you like to ask your question? Okay, I will ask it for you. So the question is, methodologically, how do you deal with structural breaks in data? And then there is more information in the chat as well.
Okay.
But that's the question.
Give me a second to read this is a bit more detailed. It's a very good question. I mean, this goes back to that point I was mentioning around iterative approach, which is kind of going back to that concept, the concept of reinforcement learning, but where we're actually doing it with domain expert or the local expert. Now, we do have a few patent pending approaches where we do fill gaps using various forms of regression and forecasting. To do it, it can be a problem. What we have interestingly found is that often data is not the best source for a model. And this is really almost counterintuitive, because data often captures so many nuances that were unique to when the data was being collected, such that people walk differently when they're in the rain versus when it's not raining. But if you didn't know that it was raining, you didn't have that data, your model won't capture that effect, so it will be wrong. Whereas a domain expert, so this could be, let's say, someone who runs a warehouse, they know from 30 years of experience, they know nothing about data science, but from 30 years of experience, they say, actually, on the second week of October, as we're getting ready for Black Friday sales, we're going to have this peak. We'd roughly have 300,000 SKUs are going to come in. We're going to have 20 extra trucks, and they just know it. They might not be able to explain it to you, but they know it. So there becomes a almost design thinking method to actually extract that information from them using diagrams, using flows, and then iteratively work it through them, but use the data as a way to evidence whether the simulation was accurate or not. Does that make sense? Hopefully.
Great. Thank you for your question, Christian, and for your answer, David. I think lastly, we'll go to Hannah. Hannah, would you like to ask your question?
Thanks, James. Sorry for overcrowding this with ODI questions. Mine's more of a general question. mostly to the fact that I'm not a sort of data person, but I'm more interested in the sort of skill sets that organisations need to implement digital twins, and what data, but also broader skills, are useful for being able to bring one together or create one.
So again, all my answers are multi-part answers. You can tell I used to be an academic. So I think at the moment, a lot of it, and this is where we're trying to move away from, you need to be an analyst. You need to either be a statistician, a software engineer, something to that effect, to reliably do it. Where we are very much moving towards is where huge amounts of the digital twin are auto-generated. So, for example, all of that map stuff around Leeds, now that we've got those data sources supported, it is a matter of plugging them back in, and then it regenerates that aspect of the model. Currently, it still needs more configuration to then make it do something of interest, but we've automated that first 50%. Where we're working towards is getting to the point where it becomes like playing something like SimCity or the Sims 4 experience, which is where it is as easy as playing a game. It is drag and drop. So where you want to do a digital twin of your office building, you can drag in your furniture. We can draw the outline, just draw it. We've already got some of those utilities that we're using for a project. And then you just drag them in, and then it auto-generates all the 3D models, the BIM information that you need. That's all there, and then you start to run it. That's where we're getting to, and it's part of being inclusive. I mean, the length of extremes that we're really passionate about here is even down to how you choose your fonts and your color schemes in these things, because most things look the same, but actually a lot of the time, there is no such thing as a standard user, and your domain experts could have no eyesight problems, no disabilities. Great. There's a lot of people there who are either dyslexic, are colorblind, all sorts of things. And any one of those, I myself am dyslexic, any one of those is a challenge when you're doing data science, because it means you can miss a whole lot of information. So choosing fonts such as the dyslexia font, embracing color schemes and color contrasts that work with different types of schemes is very important as well. So we're really trying to make that as easy as possible. And we're very much up for working with anyone and collaborating with anyone who has some great ideas around making it more accessible. So, that is also, we've got some ideas, but please come to us and say, oh, actually, could we try and do this more?
Thank you.
Lovely. We've got another quick question from Christian, which is, which sectors do you see coming up next on digital twins? What about health?
I mean, healthcare is a big one. So I think I'm going to try and remember, there's a set of core themes that have been identified by the Digital Twin Consortium, kind of as it from a global initiative. So your cities, built environment, and transport are your traditional ones, often separated into two. Sometimes acting as a separate one to that is your utilities and your subterranean or your aerial stuff. So they're not always in the same one because they tend to be a bit more specialist knowledge there and not included in open data. You then have your defense and aerospace. So that is a big sector with a huge heritage of simulation. So I'd say it's your urban and mobility, which I'll include the kind of the infrastructure, roads, buildings, utilities. You've got your defense and aerospace, and then your healthcare are probably the big areas. There are many others, I'm sure, but those are what come to mind.
Lovely, thank you. I think that is it for questions. So all that is left to say is thank you very much, David, for a lovely presentation there. Thank you to everyone who's joined us today. Unfortunately, our lunchtime lecture series will be taking a short break for the summer holidays, but we expect to be back on the 11th of September, I believe. So please keep an eye on our website for any more information coming up about the next lunchtime lecture.
Yeah. Well, you're welcome. And I'm happy to be, if anyone wants to get in touch, please get in touch either LinkedIn, via our website, or through the ODI.